We are breaking up 1.5 into two sections. So part A is today. So we are going to solve by factoring and using the square root property. So these are the ones for today. And then part B will be tomorrow, which is completing the square quadratic formula using the discriminant and finding the number of solutions, and then just solving quadratic equations in general. So with quadratic equations, we know that that is the form ax squared plus bx plus c equals 0, where a does not equal 0. A, b, and c are real numbers. To solve quadratic equations by factoring, we apply the zero product property or principle, which states that if you set them equal to 0, the two products equal to 0, then at least one of the factors equals 0. So a times b equals 0, then a equals 0 or b equals 0. So we can use that property to solve. So we are solving by factoring. So the first thing we'll need to do is factor completely, and then set each factor equal to 0, and then solve the equations and check your solutions. So example 1b is actually worked out for us, so we'll just go through it pretty quick. Here is what we're solving. It equals 0, so we are going to factor it. So that ended up factoring 2x minus 1 times x plus 1. So something that you'll have to remember is AC over B. So A times C, which would be -2, with a B as 1. So it gives a product of -2 and a sum of 1. So that would be what? +2 and -1. Okay, so then we would do our box method. And we know that 2x squared is in the top left, and then -1's in the bottom right. And then these two go in the diagonals. So this will be 2x, and this will be -1x. So then we would factor the rows and columns. So if I factor this column right here, it would be 2x. Factor this column would be a -1. And then factor this row would just be an x. And factor the last row would just be a 1. And so that is where this comes from. So you have the 2x minus 1 and then the x plus 1. So use your x box whenever you factor. And this is helpful whenever your a is a different number other than 1, whenever you have a value other than 1. So once you factor, and we know that it's set equal to 0, then we can set both equations equal to 0 and solve. So they set this one equal to 0, and then the x plus 1 equal to 0, solved. So we get these two answers. But something that's really important, and it's going to become even more important as we deal with different kind of functions and equations, is checking to make sure it actually works, because what we can get sometimes is extraneous solutions, which that means that these solutions actually do not work whenever you substitute them in. So whenever this is substituted in, it actually does work. It does check out. Okay, let's go to the next page. Okay, we can also use the square root property, which allows us, if we have a perfect square on the left, perfect square on the right, we can take the square root of both sides. Something that you do need to remember is that you're going to use positive and negative square root. So that's where you're going to get your two answers. Because you'll have one answer is square root of d, and then the other one is negative square root of d. So you can put out there plus minus, but then you're going to have to separate them out, see if you can actually solve and find one solution. Okay, so let's look at 5x squared plus 45 equals 0. We need to solve it. So we would need to subtract 45 on both sides. You get 5x squared equals negative 45. Then we would need to divide by 5. So we're getting all the way down until we can get to a square where we can take the square root. So we have x squared equals negative 9, which when we take the square root of that, x equals plus minus square root of negative 9. Do y'all remember what that is? 3i. Yeah. 3i. Yeah. So we can write it like that, or we could write it as x equals 3i or negative 3i. So you can write it either way.
Oh, just
All right, let's solve these problems here. So we would add 7 to both sides. Okay, plus minus 4i. Okay. So with the imaginary ones, we can't actually plug these in. So this next one, we have x minus 7 squared equals 36. Well, this is a squared, so we need to undo the squared by taking the square root. So we get x minus 7 equals plus minus square root of 36 is 6. So from this, we can write two different equations. We can write x minus 7 equals 6, and then x minus 7 equals negative 6. And so we would solve it. Positive 1. I don't know why I did negative there. And then we would need to substitute it in. So square root 13 minus 7 squared. 13 minus 7 is 6. 6 squared is 36. So that checks. And then the other one is 1 minus 7. I guess I should have actually squared it. That would be negative 6. Negative 6 squared is 36. So that one worked out. All right, let's look at the last one. Okay, we would need to solve this. So we would need to divide by 2 first. Okay, and then take the square root. Get x plus 6 equals plus minus square root of 12. So I would want to simplify the square root of 12. So that's 4 times 3, 2 squared roots of 3. So from this, I get x plus 6 equals 2 square roots of 3. And then x plus 6 equals negative 2 square roots of 3. Then I need to subtract 6 on both sides. They're not the same radical, so I would have to write this as negative 6 plus 2 square roots of 3. And then this one would be negative 6 minus 2 square roots of 3. We actually could have left it together and wrote it as x equals negative 6 plus minus 2 square roots of 3. So either one of those, so like either this or that could be your solution. All right, so that is it for the notes for today. So you can go ahead and work on your assignment.
Awesome.